Hey everyone. In this video, we're going to be deriving Broyden's method, this equation right here, um, uh, and mathematically, right? So basically, what Broyden's method is, it's a quasi-Newton method where we use a Jacobian and we update the Jacobian, right, um, to get to to get to a better guess. And so uh, the quasi-Newton method, this here, it assumes linearity, specifically j sub n xn minus x minus 1, and then equals f of x sub n minus f of x sub n minus 1. So let's get into this actual derivation, right? So if you can imagine, when we find our zero, right, um, you have uh, you have zero at a point. Oh, it's just lagging. Okay, f of x sub n, right? Um, and so that's going to be zero because at the x that is your zero, your function equals your zero, right? And that plus our Jacobian n um, times, let me zoom out a little and scroll over, yeah, times j of n and then x sub n plus 1 minus x sub n equals 0. And so x sub n is um, so basically this happens because in theory x of n plus 1, once you hit 0, it should just be the same. It shouldn't keep going. So I mean, and then this is 0, you get the term equals 0, right? But in practice, that's not really what happens. Usually what this equals is f evaluated of the next function, right? And then you're still going to have this f of x sub n, and you're going to use your updated Jacobian. So Jacobian n plus 1, x sub n plus 1 minus x sub n, right? And now if you subtract these two equations, like bottom minus top, so this is a negative equation, right? What you're going to get is these two cancel, and then I'm going to make this xn plus 1 minus xn delta x, right? You're going to get j sub n plus 1 minus j sub n times delta x equals f evaluated at x n plus 1, right? Now let's go down. And so Broyden decided to use a little bit of trickery to get us to where we need to be, right? So imagine there's a vector u such that delta x dot u equals 0. That means these two vectors are perpendicular, right? And imagine, so in such case, in such case where delta x equals u somehow, then this expression here, f of x sub n plus 1 equals j sub n plus 1 minus j sub n times u, right? Because we're just substituting. Now, Broyden used a very, very cool theory. So if I have two vectors, v dot v, that equals their magnitude squared, or it also equals the transpose of v times, where this is matrix multiplication, not a dot product, v. Um, and this is really, really cool for us because we can at least turn this right-hand side into something very nifty. Because, um, yeah, we can turn this right-hand side into something very nifty. So f of x sub n plus 1, right? Um, divided by delta x squared equals delta x transpose times u, right? And then this just equals f of x sub n plus 1, because the rest of it we prove that they're all equal, and u equals delta x. And so that is equal to this expression, jn plus 1 minus j of n u hat u. And so these u's cancel, right? And then so we get jn plus 1 minus j sub n equals f of x sub n plus 1 delta x transpose over delta x squared, right? And then what we're going to do with this, we need to get it, we're going to use the fact that we need a delta fn on the top, if you remember our first equation, equals f x n plus 1 minus f x n, right? And so if you add that over, you get your expression. And then if you go all the way back up here, f of x sub n equals negative jn delta xn, right? Because these equal 0. So if you subtract that over, you get negative j delta xn. And so if you do that substitution, what you're going to get here is, excuse me, delta fn minus j sub, sorry, this should be n plus 1, I believe. Let me check real fast. Yeah, it should be n plus 1. J sub n, sorry, this should be n plus 1, delta x transpose, oh, sorry, j sub n times, right? And then it should be delta x. Oh, the color, let me switch that. And then let's multiply that by the transpose plus j sub n equals j sub n plus 1. And so let's take this. So this should be delta x squared. And let's take this and go back to Broyden's method. And if you replace the n plus 1s with n's and the n minus 1s with in the n's with n minus 1s in our formula, you're going to get this exact same thing. And if you don't, and I just realized that I forgot to do this, but it should be important to know that here it should be delta x sub n plus 1. So when you do all of these things with the delta x, they always have a sub of n plus 1. And so that's how we mathematically derive Broyden's method. I hope you guys enjoyed. Thank you. Bye-bye.